Start recording. No, skip. Remind me later. Thought I just updated. Okay. A hydrate is a salt, an ionic compound, and those two mean the same. So all salts are ionic compounds. All ionic compounds are salts. Okay? Well, there's a couple exceptions, but we're going to pretend we don't know about those. Okay. So that is what a hydrate is. But, so this is, what do we call this structure? This is called a crystal lattice. Okay? And what happens is, can we pretend that this is a water molecule? Kind of looks a little like a water molecule with like the O and the two H's. We good with that? What do you notice about this structure? What's it like in the middle? Yeah, it's hollow. Just enough room to fit something quite small, like a water molecule. Yes? So a hydrate is a crystal lattice, an ionic crystal lattice, that has water molecules embedded within the crystal lattice structure. Does that make sense? So we have a little picture of that over here. You can see here is our crystal lattice. This right here is an ionic bond. Okay, and inside each of one of those little squares is a water molecule. Question for you. Often when people hear the word water, they think dissolved. Is this solid, liquid, gas, aqueous? Solid, liquid, gas, aqueous. Solid, okay? It's a solid. It's still a crystal. It just has little water molecules in it. It's not like the salt is dissolved in the water. The ionic bonds are not broken. It has not dissociated. Yes? So this is a solid, and the water is just part of that solid. So the water itself doesn't have a state of its own. It's just part of this hydrate, which is a solid. Okay? Another word you should know is hydrated salt, which means exactly the same as the word hydrate. Okay, and hydrate, I guess I could have highlighted that it has water molecules embedded in the solid crystal lattice. Now, an anhydrous salt, usually the prefix an means without. It's the crystal with no water in it. Okay, so this would be an anhydrous salt. All right. Hydrated salt. Anhydrous salt. What do you think is holding the water inside the crystal lattice? Have a chat with your neighbor about that. What is holding the water inside the crystal lattice? What kind of? Water bonds. I've never heard of those before. What kind of bonds do we know about? We know about covalent bonds. We know about ionic bonds. We know about intermolecular forces. Yes. Okay, there are also metallic bonds. We haven't dealt with those yet. We might look at them later in the course if we have time. Okay, but for now, those are the three types we have. What is holding the sodium and chloride together? That's an ionic bond, okay? So that's between the ionic bonds. Are ionic bonds strong or are they weak? They are strong. What is holding the water molecule? Oh, what's holding the hydrogen to the oxygen? That's a covalent bond. Non-metal, non-metal, covalent bond. What's holding the water inside the crystal? What? Intermolecular forces? Yes, you're correct. It is intermolecular force. Yes, you did, and you put your hand up and you spoke loud enough that I could hear it. Excellent. Thank you very much. Okay, you don't have to whisper, and you know what? You can be wrong too. Have I ever told you guys about what was her name? Allison. She was in my first AP class. Okay, first class of AP, went through the program the first time with me. Allison Dennert, that was her name. And she would answer all my questions, which was wonderful. Loved it, okay? It was a very interactive class, so it was a lot of fun, okay? The more you answer, the more fun we can have. Every time she answered a question, it was wrong. Okay, she got the answer wrong every time. Do you know what the top score is on an AP exam? A 5. What did Allison get on her AP exam?
6.
She got well, you cannot get a 6, but she got a 5. Do you know why? Because she had processed all her ideas. She's gotten all those wrong ideas out there and was able to make those corrections. And she didn't get like upset about it or anything. I know it can be hard. Sometimes it's like, oh, I don't want to be wrong in front of all my peers and stuff. But if you can get over that and just be like, I don't care. I can be wrong every single time and I can do well later. So I don't care what these people think. Right? So anyway, I know it's hard to do, but if you can get over it, it can be a really powerful learning tool, is just having that dialogue. It's almost, and if there's only one person answering me, it's almost like you're getting a private tutoring session with me. Yeah? I've got one person in block 7 who literally like asks me questions all the time, and it's literally like they're getting a private tutor session because nobody else is talking, right? All right, anyway, let's see. So we have hydrate, hydrated salt, and hydrous salt. How can we go from having a hydrated salt to having an anhydrous salt?
Heat it up.
Heat it up. What's going to happen if we heat it? What's going to happen to the particles? They're going to start moving faster. And they move faster, and they move faster, and they move faster until there's enough energy that what happens? The intermolecular forces break and... Okay, the water comes out as a gas. Yes? So this is the process called dehydration. Okay, dehydration is the process whereby a hydrate is heated and to form the anhydrous salt plus water vapor. Okay, the IMFs are broken. Now, if we remind ourselves, ionic bonds, are they strong or are they weak?
No.
Ionic bonds are strong. IMFs are weak. Okay, so these are stronger than those. So although the IMFs will break, will the ionic bonds break? No, not unless we heat it a lot higher. Okay, the IMFs will break around 100 degrees. You would need to heat this to several thousand degrees to get the ionic bonds to break. Pardon me?
When you said 100 something, I was thinking of double of that.
Oh, yeah. No, more than that. Okay, so that's why if we have our hydrated salt, here we have our ionic bond. Between the calcium and the sulfate. And you can see that after it has been heated, we still have an ionic bond between the calcium and the sulfate. It does not break. But we also had intermolecular forces those IMFs will break when we heat it, and so the water can escape out as molecules of gas. Is good? Okay. And as I said before, many students will think that a salt with water in it has to be a liquid, but it's not true. The water is just little bits in the solid. Okay? And now we're going to learn how to name them. Naming them is pretty straightforward. So basically, you name the anhydrous salt, which means you are naming an ionic compound. Do you know how to name an ionic compound? Yes. And then afterwards, we add the word hydrate with the appropriate prefix. And what are the prefixes? Mono, di, tri, tetra, penta, hexa, hepta. Okay, octa, nona, deca. I'm not going to be done for a good 10 minutes, so okay, yeah. Now, one thing we're going to notice about the formula, and we're going to take a look at a few formulas. So here is the formula of a hydrate. There is a dot in the formula, okay, in between the ionic compound, the salt, and the water. That dot can almost be thought of as representing intermolecular forces. Okay, so we haven't crunched it all together. We haven't just said NH4 2C2O4H2O. Like, we haven't made it all one, because the water isn't held there as tightly as if it were bonded. Okay, so the dot can be thought of as IMF, so you can break it off. Okay? And so in order to name this, we would simply say NH4 is ammonia, C2O4 is oxalate. You can look that up on the not on the periodic table, on your pink sheet if you don't know that. So we have ammonium oxalate, and then you'll notice there is no number in front of that water. No number in front of water. How many waters do you think that means? 1. So what that tells you is that there is 1 water molecule for every 1 NH4 2 C2. Sorry, pen's driving me crazy. C2O4 formula unit. So it's a 1-to-1 ratio. So for every 1 salt particle, you have 1 water molecule. Okay. And what do you notice about the name? Do we have a dot in the name? No. Okay, there's no dot in the name. So formula gets a dot, the name, no dot. Let's take a look at this next one. We have calcium. You'll notice calcium is not in the red zone. And because it is not in the red zone, what do we not use? No Roman numeral. So we just have calcium, and we have N. What's the name for N? It's nitrogen, so it would become nitride. So we have calcium nitride, and then we have 2 H2O molecules for every 1 Ca3N2 formula unit particle. Yeah? So 2 water particles for every 1 calcium nitride particle. 2 to 1. And we name it calcium nitride, and then because we have 2 waters, it's dihydrate. Yes? Okay. Why don't you guys try, can I get this off the screen? Mostly. Yeah, there we go. Can you try naming this one KCH3COO? I know the answer's there, but just try without looking. .3H2O. So I've noticed a lot of people have been spelling potassium with 2 T's and 1 S. It's 1 T and 2 S's. You can always check on your periodic table. So we have that K, and then we've got this whole huge thing over here. Remember, there's only ever 2 ions, yes? There's never 3 ions for you to name. So you look up CH3COO-, and that is named acetate. If you named it ethanoate, that would also be fine. Okay, so we have potassium, acetate, and then what? Trihydrate. No, good. That's what you should be saying. Yeah.
Why is there a dot there?
Yeah, why is there a dot there?
That's like kind of wrong.
That's like kind of wrong. Absolutely.
That's gonna assault my senses.
Right? I know.
Oh, that's good.
Okay? So I'm going to throw up mistakes always. You know, I like throwing out mistakes so you can correct them. And sometimes I throw out mistakes just because I've made a mistake. Ha! Okay. All right, now we have this one here. Remind ourselves, Fe. Does Fe need a Roman numeral? Yeah, it's in the red zone. So why don't you guys try naming that one? FePO4.4H2O.
Oh wait, we have to put a big roll. Wait, Jaker. Iron phosphate.
How many phosphates do we have? Do we have 4 phosphates or 1 phosphate? 1 phosphate. Because the 4 is part of phosphate.
State. Is it ethanoic or?
You could call it ethanoate.
Because ethene is something entirely different, if I'm not wrong, right?
How do you spell that?
ETHANOATE.
Okay, thank you.
Yeah. Okay, phosphate is 3 minus, therefore iron must be 3 plus, which means our Roman numeral is 3. Excellent. It's really nice teaching naming to grade 11s because you guys have done it like twice already. So, you know, we spend a lot of time trying to tell the grade 9s that it's not the number of atoms, it's the charge. And that takes a long time. But you guys have had a long time now, so that's good. And then, what's the prefix for 4? Tetra. Tetra.
What in these wrong?
Okay, I will tell you that people are going to write this. There's going to be people who write this, and I'm going to be like, no, it's not hydroxide. It is hydrate.
Well, you know hydroxide is a whole different thing.
Yeah, it's a whole different name. I know. And yet, it is a common error. Because people's brains just go sometimes, right? Everybody's brain does that sometimes.
Was it really?
Okay. So writing the formulas, all you got to remember is the dot and then a coefficient in front of the water. So let's take a look at copper 2 sulfate. Copper 2 plus, sulfate 2 minus. So that's going to become CuSO4. What's penta? 5. So it's going to be dot 5 H2O. Barium. Barium is in column 2, therefore its charge is plus 2. Hydroxide is OH minus. And then hepta means 7. Okay, so here's our formula. BaOH2.7 H2O.
Wait, what? Oh, no.
I'm just waiting for everyone to pay attention. And remember, I'm checking to see if you're paying attention. And I literally, in my last class, someone was like, I'm paying attention, and then didn't notice. What have I done wrong? I need to have brackets. Yeah. Okay. Very good. Alrighty. So there are some exercises here. We have now finished everything that you need for this unit. So if you did not do quizzes 9 and 10 yesterday, you can do them today. If you need to get caught up on previous quizzes, you can do that as well. These guys right here are hydrate practice, quiz 11. And if you have time, you can go ahead and work on the review. If you're like, I have done enough review and I know how to do this, I am good, you can work on organic, get some enriched credit. Okay? Let me know if you want that. I need to make another copy or 2 of it. Yes. So let's find out what you're missing here.
Is it possible to do a lemon as well?
Oh yeah, you can do however many you want to. So let's see, you're here. Sambed. So you just, yeah, you're all caught up to there. So you would just need to do 9, 10, 11. Yeah. Ella, I think you are all caught up. So you just need to do 9, 10, 11. Yep. You got 6, 6, 6, 6. Perfect. Yeah. Oh, and I also want to give you your progress reports.
I don't want to. I don't want.
I'm gonna get Lassia her test first though, because I could not find it.
I don't even want to see it. You said there's a difference between English and the test, right? So is it for 30%? 4%? You know, when the design.
This is for 10%.
Yeah, and test for like
No.
over 7.
Something like that.
Yeah.
80% maybe. And then there's like labs. Yeah. Yesterday was quiz 6. Yeah. Okay.
If I grab it, I can figure out my entire life.
Yeah, I'll get rid of this for you.
How is this? That's right. Everyone was doing that. But this was right. Right. I was saying here, oh, when I showed them,
I think I got to look there. There is no look at it.
This one is these are all.
Why?
Why? Because they're no, that's
chart
for COO.
Also, if they have COO there.
Yeah.
No.
Normally the H goes in the front.
So always, even if it's not there, there's no height to it, it still goes to the front.
Yeah.
Or
At that one, you would have to buy templates. You would have to look at patterns and figure it out on your own. Have fun.
very clear.
You don't need to. Pardon me? You're never in my room. Sorry.
Okay, so.
So you got rid of one.
Listen,
Oh, okay.
If it's actually O, you understand. Then that means like anything of the acid will be. Hold on.
Now, does anyone have any questions before I start handing out things?
If you change, if it's the name of your thing is where you change it to ACC, that's the one that changes. No, change it to I. Yeah. I that's what it's doing. Yes, because ICB was a normal one, still change to A. So if there's no hydrate, it's not, you don't write it, but it's writing the acid. So usually if there's like normal ones like this, they go like hydro something, they have H. If they don't have H, they just go like something acid. No, I.
I hate something.
Basically, if you don't have the H, that's different.
Well, that's another way to do it.
But organic stone, what do you get? There's like.
But then you got
What's
long
the
US.
See.
Not odorous, you need odorous. That's why my spray is the good ones.
Okay. Here. It's only good. I'm sorry, no, I don't have it.
Oh.
You got a problem?
Yeah.
Oh, right, that's right. And if there's an H called like hydrocarbonic acid. Which is, this situation, what's the reaction to this?
You get to choose the third one.
Some of them don't even have, oh yeah, I mean, you write the H in the formula.
Let us find.
Yeah, or you know what it is, like, why do you go?
Huh?
Wait, you said you write H in it, like in the parts.
H goes in the front unless it's an organic acid.
How do you know if it's organic?
It ends in COO.
Oh.
Okay, so if you see the COO,
Mhm.
then the H goes on the COO.
And
COO
when do I
H.
write the H? Like when I'm writing the name of the formulas? Because sometimes we have hydro something acid, some just have this something acid. And what's the difference of that? Is it still the
That's to do with whether it's an ide
yeah, and eight?
or eight or ite. So
Okay.
if it's an ide ion, it's going to be hydro whatever ic
Oh,
acid.
so- okay, and if it's an eight, there is no hydro.
It's just ic, and then if it's ite, it's us.
Or us, yeah.
Yeah.
Or you guys.
Yeah, yeah.
Oh, we do that for sulfur and phosphorus.
Hmm?
We just do the H, right? That's fine.
Yeah, yeah, perfect. Sorry. Confused for a minute, but now I'm not. Where have you put your progress reports? I had them 2 seconds ago. Everybody.
Alright, so there's no way that was good. See how I do the six, like, look. I can read this and, switch colors, the green, shares. Is this mine or no?
Did you do quiz 8? Yes, that was the first one we did.
Oh.
Yep. Sulfuric, yeah. Yeah, sulfuric, yeah. Uh-huh. Sulfuric, that was hydrosulfuric. It has a hydro. Yeah? Yeah, cool. Printing these out again? I guess I am. Evan. Taranyu. Beta. Should I do this later? I should do this later when you're not writing your quizzes. Sambit, did you want your progress report? There you go.
Thank you.
Yes. Do you know where to find it? I'll come show you. Okay. So let's go back here. Okay, I'm marking these now. That's what I'm doing. Yeah, I'm gonna pack out of here.